Curiosity rover detects habitable Earth-like past on Mars, but how did oxygen get there? Rocks scrutinized by the Curiosity rover in ancient long-dried lake bed on Mars have revealed conditions likely to have been habitable billions of years ago. And there, in rocks on the Gale crater, Curiosity has found a surprising amount of manganese oxide. It's a mineral that is commonly found in lakes on our Earth due to the highly oxidated conditions therein, which causes manganese crystals to form in the presence of oxygen. Its discovery on Mars in such great quantity suggests that perhaps similar conditions persisted in the Gale crater when it was filled with water in eons past. On Earth, these types of deposits happen all the time because of the high oxygen in our atmosphere produced by photosynthetic life and from microbes that help catalyze those manganese oxides reactions, explained geochemist Patrick Gasta of Los Alamos National Laboratory. On Mars, we don't have evidence for life, and the mechanism to produce oxygen in Mars' ancient atmosphere is unclear, so how the manganese oxide was formed and concentrated here is really puzzling. These findings point to larger processes occurring in the Martian atmosphere or surface water and show that more work needs to be done to understand oxidation on Mars. Manganese oxide is common and abundant here on Earth and intricately involved in biological processes to boot. It's an essential mineral for several human biological processes, but pretty much all life on Earth requires manganese for some reason or another. There are even bacteria that rely on the oxidation states of manganese for energy, and their presence can accelerate the oxidation process. There is not a lot of oxygen floating around on Mars now, and we've certainly found no evidence of living bacteria, so exactly how the manganese came to be hanging around there in sedimentary rocks on shoreline deposits in quantities comparable to an Earth-like environment is not clear. Gazda and his colleagues made a careful study of the manganese as analyzed by Curiosity ChemCam, which uses a laser to vaporize minerals and then analyzes the light to determine their composition. And then the researchers explored different mechanisms for the precipitation of manganese in the Gale crater lake, precipitation from lake water or from groundwater through porous sands. All mechanisms require the presence of highly oxidized conditions, and after running through the options, the researchers concluded that the most likely scenario would have been the precipitation of manganese oxides along a lake shore in the presence of an oxygen-rich atmosphere. This is further evidence, they say, of a long-lived and habitable lake environment in the ancient lake Gale crater on Mars, since it cannot take thousands of years for manganese oxide to form depending on oxygen levels. And where that oxygen came from is another question that remains to be answered, although it's possible that meteorite impacts early in Mars history could have released oxygen from surface ice deposits. Nevertheless, the findings offer a tantalizing prospect for looking for traces of ancient life on the red planet. Microbe-mediated oxidation may have left biosignatures and organics in the manganese-bearing rocks. Perseverance, which is currently exploring a dried-up delta environment, could look for these in its travels, the researchers say. The Gale-like environment, as revealed by these ancient rocks, gives us a window into a habitable environment that looks surprisingly similar to places on our Earth today, says planetary scientist Nina Lanza of Los Alamos National Laboratory. Manganese minerals are common in the shallow, oxic waters found on lake shores on Earth, and it's remarkable to find such recognizable features on ancient Mars. The team's research has been published in the Journal of Geophysical Research, Planets, and this is on Science Alert by Michelle Starr. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.